In this video, we're going to take a look at finding the volume using the shell method. So let's take a look now at the shell method. And the shell method is different from the disc and washer methods that we've just been doing. So for our first example, I want to take a look at the y-axis. So just as we did before, we can see that this figure, if I continued it out and revolved it around the y-axis, would be reflected across the y-axis. Now, to this point, what we've done is drawn representative rectangles that were perpendicular to our axis of revolution, and so then we could visualize what that figure looked like would be a disc or a washer if I had a space in between the axis of revolution and my figure. So this part would be a washer. Down here where it's touching would look like a disc. So what we're going to do now is do something called the shell method, and the shell method requires us to draw rectangles that are parallel to the axis of symmetry. So again, if you can think about what each of these figures would look like, is I would have cylindrical shells or tubes, again many of them, and that's the difference here. Now, I'm not going to take you through why the formula is the way it is. Your book kind of takes you through that, and it's pretty straightforward, but I'm just trying to make it not the longest video ever. But that would explain why there's a 2 pi instead of just pi. So my formula here is 2 pi, and then integrating from a to b. And then I'm going to take the radius with respect to x, and then the height with respect to x dx. So let's take a look at my figure so we can see which value is which. R of x would be the radius of the shape. That's this guy. So again, if I had that figure on the other side, so from the y-axis to my representative rectangle would be the radius of my figure. Then if I look at the h of x represents height. So this distance from here to here would of course be the height. So keep in mind that if I had, for instance, 2 figures that intersected, as I have in some of my other examples when I was doing area or volume, that h of x would be f of x minus g of x, again because we're trying to find the distance between the top of the curve and the bottom of the curve. So for my first example, h of x is just simply going to be h of x. Now looking at the same method but on the x-axis, rotating about the x-axis, again, what I'm looking at is a rectangle that is parallel to the x-axis. So I'm looking at something like this. Again, this would be reflected over, and then my figure would be a shell or a tube that looks kind of like that. So if you can try to get a visual. Again, looking at that formula, it's still 2 pi. Now we're going to go from C to D, just because quite often when we're looking at integrating with respect to y, we use C and D instead of A and B, just for clarity. And we're still using the radius, but now it's the radius with respect to y, and the height with respect to y, dy. And just as we talked about over here, it's possible that h of x is f of x minus g of x. So I'll write that down. F of x minus g of x. So over here, that's really the same thing. The radius would be the distance from the x-axis to my figure, and the height is sort of like the width, so the height of the rectangle, again with respect to y. So this will make a lot more sense once we do some of these examples, but again, just to remind you, it could be that h of y is f of y minus g of y, as we did in some of our other examples. So let's take a look at a first example together. I want to find the volume of the solid formed by revolving the region bounded by y equals radical x, y equals 0, and x equals 4 about the y-axis. So we're starting with a y-axis question so we can differentiate with respect to x. So again, the first thing I would do is graph, give me an idea of the figure that I'm working with. And again, this is the region that we're talking about. And rotating about the y-axis would give me a reflection across the y-axis. And keep in mind then that my representative rectangle would be parallel to the y-axis. So again, this distance is the radius, and this distance is the height. So I'm going to copy down my formula, just so we remember. We have 2 pi, again from a to b, of r of x, h of x, dx. So what I need to do is think about how could I determine the distance of r, the radius, and how could I determine the distance of h, or height. So looking at the r value, I should keep with red since I started with red. So looking at radius, keep in mind that radius would be exactly whatever the x value is. That's how far the rectangle is from the y-axis, is the distance of x. So that made it very easy that r of x is equal to x. Now, what is the height of my rectangle? The height of my rectangle is just whatever my y value is. So if I think about this being my y value, of course, then my h of x is equal to y. But the problem is I can't use y because I'm integrating with respect to x. So I need to think about, what does that mean? Well, I know that the y value is going to be whatever the square root of x is, based on this bound of my region. So that is how I'm going to solve this question, again, with everything with respect to x. So let's start plugging values in. The volume is 2 pi. From a to b, remember I'm across the y-axis, but I'm differentiating with respect to x, so it's from 1 to 4. Again, that gives me, from 0 to 4. R of x is x. H of x is radical x, or root x. Doing some simplification, this is x to the first. This is x to the 1/2. And so I have x to the 3/2, because our rule says if we have the same base, we can add exponents. So x to the first and x to the 1/2 is x to the 3/2, because 1 is just 2/2. dx. Again, now I'm going to integrate. So the antiderivative of x to the 3/2 is x to the 5/2 divided by 5/2. But of course, I don't want to divide by 5/2. So I'm going to say this is x to the 5/2 times 2/5. So I'm just multiplying by the reciprocal, again, from 0 to 4. So let's go ahead and work that out. I'm going to keep my 2 pi on the outside. And in fact, I'm going to bring 2/5 to the outside as well. So that's going to give me 4 pi over 5 on the outside. So I just have to deal with x to the 5/2 for 4 and x to the 5/2 for 0. So this is 4 to the 5/2 minus 0 to the 5/2. So I have 4 pi over 5, and then 4 to the 5/2. Remember, this tells us to take the square root, and this tells us to take that to the 5th power. So the square root of 4 is 2. 2 to the 5th power is 32. And then, of course, 0 to the 5 halves is 0. So I have 4 pi over 5 times 32, and that gives me 128 pi over 5 for my final solution. Here's another question for us to try, and this one's very similar to the last, so if you're feeling somewhat comfortable with it, go ahead and try this question on your own. When you're ready, press play to see how you did. So again, the first thing I would do is graph that function, and I'm looking at a triangle, and again, it didn't say explicitly within the first quadrant or also bound by x equals 0 and y equals 0, but that's what we're dealing with, is this triangle. And if I revolve that around the y-axis, I would end up with this figure. And again, we're thinking about a representative rectangle that is parallel to the y-axis, since we are revolving about the y-axis. So we're drawing that line parallel. And just as we did before, this region is r of x. Whoops. And I do want to point out that in your textbook, it actually calls it p of x. But I think r makes more sense because it is a radius. And again, this value is h of x. So just as we did before, we need to think about what represents r and what represents h. So if I'm looking at r of x, just like my last example, would be whatever the x value is, and h of x, just like on my last example, would be whatever the y value is. And again, I'm not able to put both x and y in my integral, so I'm replacing y with what function would give me the y value, which is 1 minus x. So now I'm going to set up my integral. So to find the volume, I'm going to take 2 pi, and then my limits are 0 and 1. So from 0 to 1 of x for r of x, and 1 minus x for h of x, and then dx. So again, just to reiterate what the formula is, from a to b, and then r of x, h of x, dx. So again, keep in mind that this could also be called p of x if you're looking at your textbook. So pretty easy integration on this one. I have 2 pi, and then this is from 0 to 1, and I'm going to distribute the x, so I have x minus x squared dx. To integrate, I have, again, using the power rule, I'm increasing the exponent by 1 and dividing by that exponent, so x squared over 2, and then x cubed over 3, and evaluating from 0 to 1. So I have 2 pi, plugging in 1, I get 1/2 minus 1/3, plugging in 0, I would get 0. Again, you can combine these by making a common denominator, so multiplying that first fraction by top and bottom by 3 gives me 3/6. Multiplying the second fraction top and bottom by 2 gives me 2/6. So I have the volume is equal to 2 pi times 3/6 minus 2/6 is 1/6. So that gives me 2 pi over 6, which reduces to pi over 3. So that is my volume, is pi over 3. Let's take a look now at an example where we are revolving our function or our region about the x-axis. So obviously that means we are going to differentiate or integrate, with respect to y. So again, the first thing I would do is to graph the function. And I'm using Desmos as I always do, just to make it easier. And I'm looking at the region bound by x equals 0, y equals 4, and that function. So I'm looking just at the right side of this parabola, right here. And then again, that would be revolved or reflected across, and it is actually being revolved around. So again, thinking about that representative rectangle would be parallel to the x-axis, and again, we're thinking about the shells that would look like this. I know, my artistic ability is astounding. So again, we need to think now about our formula, and our formula for volume is 2 pi, and then C to D, and then R of y, or your book calls that P of y, H of y, dy. So that's our function. And so now we just have to determine what each of those values are. So I'm going to clean up my cute picture. And again, think just about this rectangle. And the radius would be the distance from our axis of revolution, which is our x-axis, to our function. So that's r of y. And then our height would be the distance across. So that's our height. So just as I did before, I want to think about what each of those values would be. So what would be my radius? Well, my radius is just going to be the y value. So whatever value I have for y is going to be equal to my radius of my figure. The h of y is kind of like the r of y in our last example, where I had to do a little bit of work. So the r of y is going to be whatever my x value is, just as it was in our last example. But in my last example, I had to do some work to get the value in terms of x. So that's what I'm going to have to do now, is do some work to get this value in terms of y. So again, I'm going to use this function because that function would represent the value. But notice that function is in terms of y. So y equals, so it's in terms of x, excuse me. I have y equals 4x squared. I need to isolate the x. So I'm going to take y divided by 4 to be x squared. Taking the square root, plus or minus the square root of y over 4 gives me x. Now keep in mind, I just want the positive side, so I only need the positive. I don't need plus or minus. And I would take the square root of y over the square root of 4, so I'm just going to simplify that to the square root of y over 2, because the square root of 4 is 2. So that is now going to be, radical y over 2 is going to be my height, because it is my function written in terms of y. So now let's find our solution. I have 2 pi, and then again I need to know what are my limits of integration. And looking at this, I can see that on using the y values that I'm given the limit, so I don't have to do any work. So from 0 to 4, 0 to 4. Again, the radius we said was y. H of y is the height, which is radical y over 2, and dy. Now I'm going to try to do just a little bit of simplification. I'm going to take this 2, which is essentially like a 1/2 because it's divided by 2, and I'm going to move it to the outside. So I have 2 pi, and then I have divided by 2. So on the outside now I just have pi. And then again from 0 to 4, and I want to combine now this y and this y. So I have y to the first, and then I have y to the 1/2, just as I did before, which gives me y to the 2/2, and then y to the 1/2 means I can add to get y to the 3/2. So that's what I have here, is y to the 3/2 dy. And then I'm going to integrate. So I have pi on the outside. Now I have y to the, remember I'm increasing that exponent by 1, so it's y to the 5/2. And I'm dividing by 5/2, but instead of dividing by 5/2, I'm going to multiply by 2/5. Again, from 0 to 4. So it's okay for me to take this 2/5 out to make things a little simpler. So I have 2/5 pi, and then I'm going to use y to the 5/2 with 4 and with 0. So this is 4 to the 5/2 minus 0 to the 5/2. We know that 0 to the 5/2 is just 0. So 4 to the 5/2, just as we had it before, means to take the square root kind of running out of room here, but remember 4 to the 5/2 is the same as 4 to the 1/2 to the 5th, and 4 to the 1/2 just means what's the square root of 4? So that's 2 to the 5th, which is 32. So down here I have 2/5 pi times 32, which is 64 pi over 5 cubic units. Let's do one more example together, and frankly I'm just throwing everything at you in this example. So this one's going to take us a little bit, and it's going to be kind of a tougher example, but let's go through it together and hopefully we'll get through okay. So we're going to use the shell method to find the volume of the solid formed by revolving the region bounded by the function y equals the square root of x minus 1, y equals 0, and x equals 5 about the line y equals 3. So this is our first time of revolving around anything other than one of the axes. So again, I went ahead and graphed this just so we could get an idea of what the region looked like. We're looking at this region bound by y equals 0, x equals 5, and my function y equals radical x minus 1. And we're revolving around a different line now. We're revolving around this line, which is y equals 3. So again, if I were to revolve that, it would look, I'm not a very good artist as we've already talked about, it would look something like this. You get the basic idea. Again, what am I going to do? I'm going to draw the line that is parallel to the axis of revolution. And this is where it gets a little bit tricky, because up to this point, I've always had this value being r, which was just the same as, you know, the y value. Now I need this value to be r. So how am I going to fix that? Well, I know that, as we just said, this value is y. So from the x-axis to our function is the same as the y value, and I need the opposite of that. So I need the other side of that line. Well, what's the total length of this line? The total length is 3, because obviously y equals 3. So if I know that together r plus y has to equal 3, then I can find that r is equal to 3 minus y. So that's the function I'm going to use for r. And good for us, it's already in terms of y, so I don't need to do any additional work. Now let's use that same thought process to find h, because again, just as a reminder, I'm looking for 2 pi, and then this is from c to d, of r of y, h of y, dy. So I've just found r of y. Now I need to find h of y. So let me switch colors here. So now I'm looking at what is this distance. That's what I want to find. Well, I know that from here to here is x. That's the x value, just like the other value was always y. So same idea. So if that value is x and this value is h, which I'm trying to find, I can use the same concept I did before and say total, this is 5. So that means that h plus x is equal to 5. So h is equal to 5 minus x. Now the problem with this one is that this is written in terms of x, and that's not okay because I'm integrating with respect to y. So now I have to do some additional math to figure out how to turn this into with respect to y, or in terms of y. So just as I did before, I'm going to go back to my functions. Remember, I know that y is equal to root x minus 1. So let's do some math here. If y is equal to root x minus 1, I can square each side to get y squared equals x minus 1. And again, I'm trying to get x by itself, so I'm going to add 1 to each side, so I get y squared plus 1 is equal to x. So I'm going to write this as 5 minus y squared plus 1, which reduces to, again, 5 minus 1 is 4, so 4 minus y squared. So this is going to be my h of y, 4 minus y squared. So let's go back up to my integral now and start plugging in values that I know. So we haven't really found the limits of integration yet, and again, this is with respect to y. Now I know that 0 is my lower limit of integration, but the question is, what's my upper limit? Now I can look at the graph and cheat a little bit and say, well, obviously it's 0 to 2, but mathematically, how would I know that it's 2? Again, because if I plugged in 5, which is this value right here, I could say y is equal to root 5 minus 1, y is equal to root 4, y is equal to 2. So that's going to be this point right here is 5 comma 2, and that's how I know that 2 is the furthest that we're going to go on the y-axis. And again, then I'm going to replace r of y with 3 minus y. I'm going to replace h of y with 4 minus y squared, and then dy. So we've done the hard part. Now it just comes down to doing, the algebra. So I'm going to FOIL this out. I'm going to get 12 minus 3y squared minus 4y, and then plus y cubed. And now I'm going to take 2 pi, and then let's go ahead and integrate. And I'm going to start with this value. So I'm going to go in the normal standard form order. So y cubed is y to the 4th over 4. And then minus 3y squared would be minus 3y cubed over 3, which of course will cancel. And then minus 4y becomes minus 4y squared over 2, which will reduce, and we'll do that in a minute. And then plus 12 gives me plus 12y from 0 to 2. So now I have 2 pi, and then y cubed over 4, again starting with the 2, so 2 to the 4th is 16, divided by 4 is 4. The 3's canceled out, so it's just y cubed, so 2 to the 3rd is 8, so minus 8. 2 squared, let's go ahead and reduce this. This is 2, this is 1. So it's just 2y squared. So I'm subtracting 2 times 2 squared, so that's minus 8. And then plus 12y, so plus 24. And then if you'll notice, if I plug 0 in, I'm just going to get a lot of zeros. So it's just minus 0. So now I have 2 pi. And then I have 4 minus 8, which is negative 4, minus 8, which is negative 12, plus 24 makes it positive 12. So my final answer is 24 pi cubic units. Great job, especially on that last example where I threw quite a bit at you at once. Coming up next, we just want to take a look at when is it appropriate to use the disk method and when should we use the shell method.